So today we're going to talk about the distance formula, finding the distance between 2 points. So if I'm given 2 points, the very first thing that I want to do is to go ahead and label them x1, y1, x2, and y2. Then I'm going to plug it straight into this distance formula right here. So we're going to do d equals, and then put a really long square root because everything that we do is staying under that square root. And so I'm going to do x2 minus x1. So here that would be 7 minus 2 squared plus, and then we're going to do plus parentheses, y squared minus y1, so that would be 10 minus 5. Close your parentheses, squared. So that's going to give me distance equals, again, make sure that you carry down your square root every time. That's where I see the most mistakes, is people just start writing numbers here. It is staying under the square root until we get one number under that square root. So 7 minus 2 is going to give me 5 squared. It's still in parentheses. Plus 10 minus 5 is 5 squared. Okay? So our distance equals, what is 5 squared? 25. Plus 5 squared is 25. So our distance is the square root of 50. Now, this is what I had in your bell ringer that some of you weren't really sure how to do. Does anybody have an idea of how we find the square root of 50? Yes?
You do like the factor tree, so you like write out the factors, and if there are two the same ones, you do outside of it, and then one's left over, stay inside.
Okay, so we are going to find factors of 50. Instead of doing a huge factor tree, I like to just find one number that is a perfect square. So what is a perfect square that goes into 50, Joseph? Okay, 25 times what gives us 50? 2, okay? So we can take the square root of 25. What is the square root of 25? 5. So my distance would equal 5, and then can I take the square root of 2? No, so I leave that under the radical, and my distance would be 5 square roots of 2. Okay? So let's try another one like that. So let's look at number 2. We're going to label, go ahead and label x1 and y1, x2 and y2. I'm going to write distance, and I'm going to put a big, long square root. I'm going to go ahead and put my parentheses squared plus my parentheses squared. I just realized that on these notes, it doesn't have squared here, but it has it on your notes, correct?
Yes.
Both of these should be squared. Okay, so in our first parentheses, we're doing x2 minus x1. x2 is negative 5 minus x1 is 0. Then we're doing y2 minus y1 in my second parenthesis, so that's going to be negative 2 minus 4. So our distance will equal, again, I'm drawing a huge square root. What is negative 5 minus 0? Nobody knows? Negative 5. Keep it in parentheses, squared, plus negative 2 minus negative 4? Negative 6. Okay, can anybody tell me what happens when you take a number and you square it? It's positive. It's always going to be positive. So if you put it in your calculator and you get a negative, it's because you're not using parentheses, and then your answer is going to end up being wrong. So for these problems, remember, when you square it, it should always be positive. So I know that 5 squared, or negative 5 squared, is 25, plus 6 squared is 36. What is 25 plus 36?
61.
Okay, does 61 have a perfect square in it? No. So that means we would leave it just like this. So So that was like your third problem on your bell ringer, the square root of 3. There is no square root of 3, so we leave it as square root of 3. So here we leave this as square root of 61. Okay, let's look at 4. So in number 4, I'm going to go ahead and label x1, y1, x2, and y2. I'm going to do distance equals, and I'm going to draw a really long square root. I'm going to put parentheses squared plus parentheses squared. In my first set of parentheses, I'm doing x2 minus x1, so that's going to be -1 minus a -3. How would I write -1 minus a -3? -1 plus 3. Very good. Then we're doing, in our second parentheses, y2 minus y1, so 2 minus 5. So that's going to give me distance equals, again, I'm doing a long square root. -1 plus 3 is 2 squared, plus 2 minus 5 is a -3 squared. Okay? So I know that 2 squared is 4. And -3 squared is 9. So that is the square root of 13. Is there a perfect square that goes into 13? Nope. So our distance would be square root of 13. Okay. Let's do one more to make sure you got that. So we'll look at number 5. So for number 5, we're going to label x1, y1, x2, y2. I'm going to do distance equals, and I'm going to draw my really long square root. I'm going to put a parentheses squared plus a parentheses squared. In my first parentheses, I'm doing x2 minus x1. So what is x2 minus x1? 6 minus 3. Then I do, in my second parentheses, y2 minus y1. 9 minus 3. Okay, from here, because I've been doing it so long, I would probably skip a step. I know that 6 minus 3 is what? 3. So I'm going to go ahead and square that 3. What is 3 squared? 9. Plus 9 minus 3 is, and 6 squared is? Okay, so you can skip those steps if you know them. Okay? Then 9 plus 36 is 45. Now, is there a perfect square that goes into 45? I believe there is. What is it? 9 times what? 5. So we can take the square root of 9 or 5? 9. What is that? So my distance will equal 3. And then can I take the square root of 5? So I'll leave it there.
What if, like, both of them, like, say,
9 times 16. You would multiply it. Oh, if you could take them both, you would be able to tell right here that it was a perfect square. Or you could break it down and you'd bring, if you took the square root of 9, you'd bring out the 3. You'd take the square root of 16, bring out the 4, and you'd multiply the 3 times the 4. Okay, next thing I want to look at is looking at the length of the lines. We're going to see if they are congruent or not. So we're going to look at a couple of these. So first, let's look at AB and CD. How do you think we could find whether they were congruent or not?
by looking at the slopes.
Not by looking at the slopes. Slopes tells us, are they parallel or are they perpendicular? We're looking at how long they are. Are they congruent? How do we find how long something is? We use the distance. Okay? So, in order to find the distance from A to B, we actually need to know what points A and B are. So if I start at the origin and I go to A, I would have to go up 1, 2, 3, and to the left 2. So what would A be? -2, 3. Okay, and then B would be, we go right 2, up 1. So it would be 2, 1. Okay, so let's find, and here again, just like yesterday, we want to label the distance we're finding. So I'm going to put AB equals, so I know which distance we're talking about. Put your square root. We're going to do parentheses squared plus parentheses squared. Now, I'm doing x2 minus x1 in the first parentheses, so that would be 2 minus a -2, which is 2 plus 2. And then in the second set of parentheses, we do y2 minus y1, so 1 minus 3. I'm going to draw my parentheses again. 2 plus 2 is 4. 4 squared is 16. Plus 1 minus 3 is a -2. -2 squared is 4. Okay, and so here this would be square root of 20. Now that breaks down, but for what we're doing to see if they're congruent or not, we don't have to break it down from there. We can leave it just like that. So the next thing that we want to do is find the length from C to D. First I need to find point C. So to get to C, I go left 1, 2, 3, 4, 5, and down 1. So that would be -5, -1. And then we find D. To get to D, I go left 1, 2, 3, and down 5. So -3, -5. Okay, and then remember, label this. So we're going to put CD equals, do a long square root, put your parentheses squared plus parentheses squared. Let me label my points. Okay, so if I'm doing x2 minus x1, that is -3 minus a -5. So -3 plus 5. And then y2 minus y1 would be a -5 minus a -1. So -5 plus 1. Very good. Okay, -3 plus 5, what is that? And 2 squared is 4. -5 plus 1 is -4. -4 squared is 16. We add those numbers together and we get square root of 20. So are these congruent or not? They are congruent. Okay. Let's try one more to make sure we know how to do that. So here we are looking at J and K. So I'm going to find the point for J first. I go to the left 1, 2, 3, 4, and up 1, 2, 3, 4. So J would be -4, 4. And then I'm going to find K. K, I just go to the left 2. So what does that mean my Y is?
0.
Very good. So it would be -2, 0. Okay? So let's find the distance of this. So I'm going to put JK equals, and then I'm going to put my square root, put your parentheses squared plus parentheses squared. We're going to do x2 minus x1 in the first parentheses. So that would be -2 minus a -4, which is a -2 plus 4. Then we're going to do 0 minus 4. What is negative 2 plus 4? 2, and 2 squared is 4. Plus, then we have a negative 4 here. Negative 4 squared is 16. So JK is square root of 20. So that's the same as those up there. Let's look at MN now. So M, I'd go right 2 and up 1, 2, 3. So that would be 2, 3. I'm sorry, it is 1. So it would be 1, 3. And then for N, we'd go right 1, 2, 3, 4, and up 1, 2, 3, 4. So 4, 4. Okay, let's find the distance of MN. So I'm going to draw my square root, put parentheses squared plus parentheses squared. I'm going to label my points x1, y1, x2, and y2. In the first, I'm going to do x2 minus x1, so 4 minus 1. And then in the second, I'm doing y2 minus y1, so 4 minus 3. So 4 minus 1 is 3. 3 squared is 9. Plus 4 minus 3 is 1. And 1 squared is... So are these congruent? So they're not congruent. Okay. Next one I want to look at is number 10, which is on the back. So number 10, we just want to find the lengths of the shortest to longest. So again, we aren't going to have to reduce these all the way down to do that. So let's start with LW. So my points for L are negative 4, 2. And my points for W is 2, 4. So if I plug into my formula, I'm going to get x2 minus x1, 2 minus a negative 4, which is actually 2 plus 4, right? 2 plus 4 is 6, okay? Then for y, we're doing 4 minus 2. 4 minus 2 is 2, okay? So if I square those, I get 36 plus 4. So square root of 40. And we're going to leave it just like that because we can compare all the other ones the same. Then we're going to find kj. So to get to k, I'd have to go left 1, 2, 3, 4, down 1, 2, 3, 4. So negative 4, negative 4. And to find j, I'd go left 1, 2, up 1. So that would be negative 2, 1. Okay, so in the first parentheses, we're doing x2 minus x1. So negative 2 minus a negative 4. That's negative 2 plus 4. What is that? 2 squared. Good. Okay. And then we do y2 minus y1. So 1 minus a negative 4. What would that give us? 5 squared. Okay. So I know 2 squared is 4. 5 squared is 25. And so kj is the square root of 29. So right now, KJ is the smallest. LW is the biggest. Now we've got to look at SF. Okay? So to get to S, I go right to up to. So S is 2, 2. And F is, I have to go right 1, 2, 3, down 1, 2, 3. So 3, negative 3. Okay? So I'm going to do three minus 2, which is 1 squared, plus negative 3 minus negative 2. What is negative 3 minus negative 2? Negative 5 squared. Okay, so 1 squared is 1. Negative 5 squared is 25. So SF is 26. So if they want us to order it from shortest to longest, what would my answer be? SF, then KJ, and then LW. Okay. Our last example, I want to go over 12 just because I feel like some people would get a little bit confused about this, but this is also the same thing that we've been doing. So number 12 asks us to find the perimeter of ABC if the vertices of the triangle are 9, 7, 5, 4, and 1, 1. Somebody tell me, how do you find the perimeter of something? Add what? Very good. Add all sides. Okay? So, just for reference, I'm going to draw my triangle real quick. Does it really matter where I put A? No. So I'm going to put A here, B here, C here. So A is going to be 9, 7. C is going to be 1, 1. And B is 5, 4. So I need to find each side. So let's talk about A to B first. So we're going to find side AB. And the way we find the length of that is we do the distance formula. So I'm going to label x1, y1, x2, y2. So this is going to be 5 minus 9. What is 5 minus 9? Negative 4 squared plus 4 minus 7. So negative 3. Okay? So this is going to give me negative 4 squared is 16. Negative 3 squared is 9. And so 16 plus 9 is there a square root of 25? 5. Very good. Okay, let's look from B to C now. So this is now going to be x1, y1, x2, y2. So I'm going to do 1 minus 5. What is 1 minus 5? Negative 4 squared plus 1 minus 4, negative 3. So what is this going to be as well? It's going to be 5 because it's exactly the same as this. So that length's going to be 5. All right, and then let's see about A to C. Or C to A, however you want to write it. Okay, since these are already labeled x1s and these are already labeled x2, let's just keep them like that. So we're going to do 1 minus 9 which is a negative 8 squared, plus 1 minus 7, which is a negative 6 squared. Negative 8 squared is what? 64. Negative 6 squared is 36. So if we add those together, that gives me, is there a square root of 100? 10. So what is the perimeter of this whole thing? Perimeter, 10 plus 5 plus 5, which is 20.